Hi everybody, so we're going to start today talking about multiplying polynomials. Now we already know how to do a problem like this one where we're distributing, so let's review that. When I distribute, I'm going to have 2x cubed times another x cubed, which is 2x to the 6th. Then I'm going to have 2x cubed times 3x squared, which would be 6x to the 5th power. Then I'm going to have 2x cubed times negative 2x, which is negative 4x to the 4th power. And then I'm going to have 2x cubed times 5, which is 10x cubed. Now that is a very long distributing problem, but it's fairly straightforward. You're just distributing whatever's on the outside to whatever's on the inside. However, sometimes we're going to have problems like this. Now what we're trying to do here is distribute two different terms, the 3x and the 4, to this other parentheses. So this gets a little bit more complex. Let's go ahead and distribute two separate times. 3x times 2x would be 6x squared, and 3x times negative 7 would be negative 21x. So I've taken the first term and I've distributed it to the 2x and the minus 7. Now I need to take the 4 and distribute it. So 4 times 2x would be 8x, and 4 times negative 7 is negative 28. Now, unlike the previous problem, when I get to this step, I realize that there are some like terms here. There's the negative 21x and the 8x. So what I would do to simplify my answer is I would write 6x squared, and then I would combine those, and I would have negative 13x, and then I would write minus 28. Now, some of you may have seen problems done this way before, but what I'd like to show you now is a new way to organize your work when you're doing these problems that will help make sure we don't miss any terms or make a mistake when we multiply. So what we're going to do right now is the exact same problem we just did, but with a slightly different organizational system. So here's what you're going to do. You're going to write the first parentheses going across. So you're going to have 3x plus 4. And you're going to write the second parentheses going down. So you're going to have 2x and negative 7. And then you're going to make a grid. So here's what that grid's going to look like. You're going to make a separate row for each of your orange terms, and you're going to make a separate column for each of your blue terms. So you're going to make a grid where the 3x and the positive 4 are at the top, and the 2x and the minus 7 are along the side. Now what we're going to do is multiply. So we're going to do the 3x times the 2x and put it in the box where that column and row intersect. So 3x times 2x would be 6x squared. Then we're going to do the 4 times the 2x and put it in this box. So 4 times 2x would be 8x. Then we're going to do the 3x times the negative 7, and we would have negative 21x in this box. And then we're going to do the 4 times the negative 7, which is negative 28. Now what you'll notice is that the purple terms we wrote in here are the same as the terms we listed here. They're just organized in a different way. Then we're going to look for like terms. Now your like terms are always going to be on diagonals from each other. So the negative 21x and the 8x will always be the like terms, which means when I write down my final answer, I'm going to have 6x squared. And then when I combine those like terms, I'm going to have negative 13x. And then I'm going to write down the minus 28. So I wrote the first box, I combined the two middle terms, and I wrote the last box. And this is the same final answer we got before with a different organizational system. Now, some of you might be thinking, Mrs. Vasta, I'm pretty comfortable multiplying this way. Do I have to organize my work this way? And my answer would be technically no, you don't have to organize your work this way. However, having this organizational tool is also going to help us a lot with factoring and getting from this answer back to the original problem. So I would suggest that you become very comfortable with this process and organizing your work this way, because in the long run, I think it's going to help you. So let's try one more problem where we organize our work that way. I'm going to write the 2x minus 5 horizontally across the top. And I'm going to write the 3x plus 4 vertically down the side. Now I'm going to draw my grid. And then I'm just going to multiply the rows and columns together. So 3x times 2x would be 6x squared. 3x times negative 5 would be negative 15x. 2x times 4 would be 8x. And 4 times negative 5 would be negative 20. Then I can see that my like terms are diagonal from each other again. So I would drop down the 6x squared. I would combine my like terms, so negative 7x, and then I would drop down the minus 20. And that would be my final answer. Now, this is a great organizational system, especially because some of these problems are going to get a little bit more complex. So, for example, in number 2, which we're going to do in a moment, there are actually 3 terms that have to get distributed. And so, seeing stuff like that, I've found that students are much more successful in getting the answers correct when they organize their work using the box method. Let's go ahead and try number 1. So I would write my first parentheses, my first 2 terms horizontally, and my second parentheses vertically, 3x and positive 2. Then I would draw in my boxes. So if I multiply, 3x times x would be 3x squared. 3x times negative 4 would be negative 12x. 2 times x would be 2x, and 2 times negative 4 would be negative 8. Now my like terms are on diagonals right here. So we would drop down the 3x squared. We would combine our like terms. So I would have negative 10x. And we would drop down the minus 8, and that would be my final answer. Now this even works when we have more terms. So again, I'm going to write my first parentheses horizontally. So I'm going to have a squared plus 3a minus 4, and I'm going to write my second parentheses vertically. So I would have 2a and positive 3. Then I would draw in my lines to make a grid. Now I'm going to multiply. So 2a times a squared is 2a cubed. 2a times 3a is 6a squared. 2a times negative 4 is negative 8a. Then 3 times a squared is 3a squared. 3 times 3a is 9a. And 3 times negative 4 is negative 12. So I'm just filling in my boxes. Now I'm going to look for like terms. The first set, what did I do here? I should have written a squared and I wrote a 6. I don't know. So my first like terms are these diagonal terms here, and my second set of like terms are these diagonal terms right here. They're already on diagonals for me, so they're pretty easy to find. So I would copy down the 2a cubed, and then I would combine 3a squared plus 6a squared would be 9a squared. 9a minus 8a would be plus 1a, and then last but not least, minus 12. Just copy it down. and that's my answer. Again, this is a great way to keep our work organized so that we don't forget any terms or miss some like terms or anything like that. Now, problem number 3 looks a little bit different, so we need to go back to talking about what exponents really mean. When I see a squared like this outside of the parentheses, what that really means is 2x minus 3, parentheses 2x minus 3. Just repeat that twice. Now, it's really important to write that out twice because then we can see that this box method would really help us simplify this problem. So across the top, I would have 2x minus 3, and vertically down the side, I would have 2x and negative 3. I'm going to draw in my boxes to make a grid, and when I multiply, I'm going to have 4x squared minus 6x, and then I'm going to have negative 6x plus 9. Now my like terms are on a diagonal right here. So I would drop down the 4x squared. I would have negative 6x plus another negative 6x, which makes negative 12x. And then I would drop down the plus 9, and that would be my final answer. If we take a look at number 4, across the top I would write t plus 5. And down the side, I would write t minus 5. Then I would draw in my grid lines to make my boxes. So when I multiply, I would have t times t is t squared plus 5t. And then if I multiply, I would have minus 5t and then minus 25. Now my like terms are on a diagonal. So I would copy down the t squared, and then I notice that negative 5t and positive 5t cancel. So I'm not going to write anything down. They cancel each other out, which means I would just drop down the minus 25, and I'm done. Now this method also helps us when our problems have x's and y's in them. So for example, I would write 3x plus y across the top, and I would write 3x minus y down the side. Then I'm going to draw in my lines to make my boxes. Now 3x times another 3x is 9x squared. 3x times negative y is negative 3xy. 3x times positive y is positive 3xy. And y times negative y would be negative y squared. Now if I look at my diagonals, these two terms are like terms. They both have an x and a y. So I would copy down my 9x squared, negative 3xy plus 3xy, they cancel each other out. That's 0. So I would just write down the minus y squared, and I'm done. Last but not least, problem number 6. We would start by writing this out and demonstrating what a squared really means. So I would have 2 parentheses 3x plus 4, parentheses another 3x plus 4. Now what I'm going to do is save the 2 for the end. And I'm going to start by just multiplying together the 3x plus 4 and the 3x plus 4. So across the top, I would write 3x plus 4, and down the side, I would write 3x plus 4. Then I would draw my grid. Now when I multiply, I get 9x squared plus 12x plus 12x plus 16. My like terms are on a diagonal. So I would copy down my 9x squared. 12x plus 12x is 24x plus 16. Now that 2 that I saved at the beginning, I'm going to put here outside of a parentheses because now I need to multiply by the 2. So 2 times 9x squared would be 18x squared. 2 times 24x would be 48x. And 2 times 16 would be plus 32. And that would be my final answer. Okay, that is the end. Thank you guys so much for watching. I hope you can see the benefits of this organizational system for really keeping our work organized and making sure that we can get the correct answer. And I will see you guys tomorrow for some practice. Have a great afternoon.